Better put my shoes on before I get hurt. Hi, my name is Zimmer, and today we will be exploring a little more about coniferous forests. A conifer is a tree that produces its seeds in cones.
Oh, so that's what these things are.
The most common example is the pine tree. The coniferous forest is a forest of conifers. The largest coniferous forest exists in Alaska, Canada, Northern Europe, and Northern Asia, in a ring around the northern hemisphere called the taiga. Trees in the coniferous forest primarily possess pine needles instead of broad leaves. Pine needles need to conserve water with a thick waxy layer that covers their surface. If you watch carefully, pour water in a pine needle. It conserves a lot of the water. The water doesn't drip away. There's still droplets of water stuck in there. Needles are an important adaptation to the extreme conditions present in the boreal forest. The boreal forest, also known as the taiga, is a biome characterized by coniferous forests. Taiga is the world's largest land biome, meaning coniferous forests make up about 27% of the world's forest cover. The taiga has a subarctic climate with a very large temperature range between seasons. But the long and cold winter is a dominant feature. Coniferous forests are cold and covered with snow for most of the year. Waxy pine needles combined with low bacterial activity in the cold subarctic climate produce a thick mat of undecayed litter on the forest floor. Pine needles contain very little sap, so freezing is not much of a problem. Since nutrients are not released, the soil remains poor and acidic. It lacks the deep, organically enriched profile present in temperate, deciduous forests. The thinness of the soil is due largely to the cold. The average temperature during the winter is negative 14 degrees Fahrenheit and 57.2 degrees Fahrenheit in the summer. Precipitation in the coniferous forest arrives as rain during the summer, and the average yearly precipitation is 12 to 33 inches. What's up? Oh God. I heard about this. Many animals live in the coniferous forest. I should check that. Wolverines, bald eagles, long-eared owls, coyotes, red-tailed hawks, snow leopards, spotted owls, earthworms, porcupines, willows, raccoons, beavers, brown bears, Douglas firs, ground squirrels, black slugs, black bears, otters, timber wolf, bobcat, red fox, newt.
Oh wow, I really hope I don't get eaten. Oh wait, isn't there a volcano nearby? Maybe it can help me get rid of these animals.
Anyways, some abiotic factors of the coniferous forest are heat regulation and soil subsoil. Because of the relatively dark coloration of the pines, more heat is collected from the meager sunlight. This helps increase the length of the growing season. The dense layering of branches and needles also creates an insulating still airspace.
If you look over there, that's the sun. Because of the dense foliage, or the covering because of the branches, the light is not really reaching the ground, which results in poor soil.
Also, over eons of homogeneity and dominance of the pine forest, the underground homeostasis has developed along with the trees themselves. Beneath their roots are many yards of partially decomposed detritus. These trees often have shallow roots that spread out widely to take advantage of the moisture in the upper levels of the ground, and also because of the poor soil and rocky conditions, much of the underground material is incompletely broken down due to the harsh chemical composition, cold and frequently frozen ground. Apparently, if this were to warm up drastically, it is theorized that vast latent stores of greenhouse gases would be produced by more active microbes, potentially triggering a cascade of increasing global warming. Whoa! Oh my God, what is that? What is that?
I think it's a volcano.
I think it's a volcano. You better run. Oh, that was good. It's gonna destroy the coniferous forest. my god, where have you been? Oh my god. I think we've been going in the wrong direction!
Everybody in the place hit the back, but stay on your. We running this.
Lava! Save yourself!
Oh my god! No! What happened?
Save the coniferous trees.
Now, we are free. We'll meet again. Not yet.
Hi, my name is Zimmer. Some of you may know my brother, Bob. He died during a volcanic eruption
10 years ago.
The site where he died. My brother was deep in the coniferous forest, exploring the details of the coniferous forest. Little did he know that his life would end that day because of a violent volcanic eruption.
Let's go! I'm on a boat!
It's so sad.
I'm on a boat!
They need to increase the warning time.
Everybody look at me!
Volcanoes. Right here, 10 years ago, exactly. At that time, forests dominated the pre-eruption landscape. Now there's no forest to be seen, only a couple of trees. Some of the animals have come back, but most of them are surviving. Volcanoes have always been in place. Forests are the ones that are coming and going. Forests grow into and around the volcano, shown by records and biological legacies of the many volcanic events are contained in deposits, landforms, and ecosystems around the volcano. As soon as the volcano erupts, the immediate environment is completely devastated, but the further you move from the volcano, the lesser the effects become. The primary physical events kill organisms, remove or bury organic material in soil, and create new terrestrial and aquatic habitats. Some small animals such as mice, gophers, and squirrels survive in their underground burrows. As they dig holes and tunnels, they also push soil up to the surface. Large ant colonies and snakes also survive in their respective dirt cities and holes. Many seeds and roots are also not destroyed because they are underground, protected by a layer of dirt or snow. Seeds lodge in the soil and take root. Gradually, birds, flying insects, and other animals move back into the devastated landscape. Despite these profound environmental changes, important legacies of pre-disturbance ecosystems persisted across much of the affected landscape. The initial events altered landforms, watershed hydrology, sediment availability, sediment delivery, the roles of vegetation and animals, and regulating physical and biological processes. Concurrently, hydrologic and geomorphic processes altered the paths and rates of ecological responses by persistently modifying habitats, thereby favoring some species and ecological processes while impeding others. Post-eruption stream flow reflects great changes in precipitation runoff relationships, structural modifications to drainage networks, and reduction and growth of vegetation.
Post-eruption vegetation development did not affect the rapid decline of hill slope erosion that ensued within months of the eruption.
Finally, loss of canopy interception as loss of forest cover allowed more precipitation to reach the land surface and reduced evaporation. It also altered seasonal variation in soil moisture by reducing transpiration. So now here we are at a lake near the volcano. Now, as you can see, the lake looks no different than it did before. 10 years later, it looks just normal. But 10 years ago, this lake was covered in tephra. Tephra had fallen on the lake, and it wasn't in the river streams. It was affecting a lot of the water cycles, the hydrological systems. So, yeah, and you can see coniferous trees growing in the back.
Life.
It's coming back slowly, but surely.
Sam out. Yeah.
Starring Mazamed. Written by Mazamed. Screenplay by Mazamed. Camera by Mazamed. Edited by Mazamed. Produced by Mazamed. And directed by Mazamed.